our quiz. Let's first try simplifying. So let's say we had secant x minus tan x sine x. So first thing I would do is I would look at secant and write that as 1 over cos x. I'm going to replace tan x with sine over cos. It's times sine x. So I'm going to put the sine x over 1. So I have 1 over cos x minus sine times sine is sine squared x over cos x. Because the denominators are the same, I can put everything over cos x and write 1 minus sine squared x in the numerator, right? 1 minus sine squared x. And then if we go to our identities, we know sine squared x plus cos squared x equals 1. And I know that cos squared x is equal to 1 minus sine squared x. So I can replace the 1 minus sine squared x with cos squared. So we're going to replace right here. So we have cos squared x over cos x. And we can divide a cos out from the numerator and denominator. So if I have cos x times cos x all over cos x, one of these cancels. So our final answer is cosine x. Simplify. Okay, let's look at another one. So for a second type of simplified problem, we could have the following. We'll call this number 2. We could have secant x all over cos x minus tan x all over cotan x. Now, I could see the problem originating that way, or I might see it as secant x minus tan x all over cotan x. Now, if this was a product in the numerator, I would flip this cotan up and write tan in the numerator. However, because I see a plus or minus in between terms, that's when I would break it up into two parts, two fractions. So that's when I would break it up to secant x over cotan x minus tan x over cotan x. So if you saw it like this, I'd break it up into 2 parts. So coming back over here on the left, we want to replace secant, cosecant, and tan usually with sine and cosine. So I'm going to replace secant with 1 over cos. And we had that still over cos. And then minus tangent we can replace with sine over cosine all over. Cotan is cos over sine. Now I want to simplify the fraction on the left first, simplify on the right, and then combine if needed. So I have the numerator 1 over cos divided by the denominator cos x over 1. I'm going to keep 1 over cos. I'm going to change the symbol, and I'm going to change the other side to 1 over cos. Now I have 1 over cos squared x. That was my numerator, right? The original problem. Now I'm going to simplify the other side. So I have numerator sine x over cos x divided by cos x over sine of x. And then we can write sine x over cos x, change division to multiplication, flip fraction on the right, so sine x over cos x. And then we would have in the numerator sine squared x over cos squared x. Because the denominators are the same, we can combine these fractions. So in the numerator, we have 1 minus sine squared x. In the denominator, we have cos squared x. And if we go to our identities, we can replace 1 minus sine squared x with cos squared x. And we can cancel out cos squared numerator and denominator, and our final answer is 1. Let's head on to another problem. Let's do a few solving. So let's say it said solve. And it asked us to do the following. It said 3 tan squared x minus 9 equals 0. So we'd first add 9 to both sides. So we have 3 tan squared x equals 9. Then we would divide both sides by 3. So we'd say tan squared x equals 9 divided by 3 is 3. And then we take the square root of both sides and we'd write plus or minus. So we'd have tan squared x equals plus or minus root 3. Now I want to pause for a sec. And when you isolate, and if you said 1 over 4, square root of 1 over 4, that's square root of 1 over square root of 4, which is 1/2. If you had, for example, 3 over 9, you would have root 3 over root 9, which would get us root 3 over 3. If, let's say, someone had square root of 1/2, you would say square root of 1 over square root of 2, which is 1 over root 2, and then you could rationalize, multiply by root 2 over root 2, and you'd have root 2 over 2. Okay, so simplifying radicals, just a quick review of that. So coming back to the problem, we're asking ourselves, oops, this should just be tan, right? Let's go back for a second. So I have tan squared x equals 3. I take square root, plus or minus, this cancels, so I have tan x equals plus or minus square root 3. So I need to ask myself, as I spin around the unit circle, where do I have a tan value of positive root 3? And as I spin around the unit circle, where do I have a tan value of negative root 3? Well, when you look at your unit circle, you know you have a tan value of positive root 3 up here at 60 degrees, right? Tan right here is root 3. So we know this little sliver is 30. I'm going to reflect 30, 60, reflect 60, 30, reflect 30, 60. So I have a tan value of positive root 3 here, first quadrant, and in the third quadrant. So we're going to say we have a tan value of positive root 3 when x is 60 degrees, and when x is, we'd say 180 plus 60. So 180 plus 60, which is at 240 degrees. Then we would say, where do we have tan value of negative root 3? So negative tan value we know is going to be in second quadrant and fourth quadrant. So right up here, we would have 90 plus 30. So 90 degrees plus 30 degrees, which would get us 120 degrees. And then we have 270 plus 30, gets us to that terminal spot. So we're at 300 degrees. So we have 4 answers, 120, 300, 60, and 240. Remember, if you need to convert to radians, you could take, for example, 60 degrees and multiply by pi over 180. So you'd get pi over 3, right? Now I'm going to stop here, and then I'm going to do 2 factoring problems. Actually, I'm going to do 1 factoring and 1 quadratic formula problem.